So we're continuing on with quadrantal angles. And like I said, in this example, they're asking us to evaluate each of these trigonometric functions at their quadrantal angle. So this first one says tan of pi. So in my mind, I'm thinking, I know, this is 0, this is pi over 2, this is pi, this is 1.5 pi, and this is 2 pi. So tan of pi, well, that point would be -1, 0. Right? And like I said, if we're looking at a unit circle, that's why we're getting that -1, our radius is 1. And I know that tan is my opposite over my adjacent, which is really y over x. So in this case, my y over x would be 0 over -1, which would be 0. You all agree? Fantastic. We're going to do the same thing for cosine 3 over 2. So for cosine 3 over 2, cosine is my adjacent over my hypotenuse. My adjacent is x, my hypotenuse is my radius. We're looking at 3 over 2, so we're down here at, what would this be, 0, -1. So my x is 0, and my radius we said was 1, so this one again is 0. Like I said, the only possible answers are 0, 1, -1, and undefined. So there's only 4 possible outcomes for quadrantal angles. So the next one is tan pi over 2. Pi over 2 is up here, which would be 0, 1. We know tan is our opposite over our adjacent. Opposite is y, my adjacent is x. So this looks like that's my x and that's my y, right? So this is going to be 1 over 0, undefined. So that's how we find the values of quadrantal angles in a nutshell. So in this section, they also ask us to name the quadrant which theta lies. They're giving you 1, 2, 3, 4 scenarios. In this first scenario, it says sine theta is less than 0 and cosine theta is greater than 0. Well, what do we know about our trig functions and the quadrants in which they lie? We have 4 quadrants. And we know in the first quadrant, all of our trig functions are positive. In the second quadrant, only sine is positive. In the third quadrant, tan is positive. And in the fourth quadrant, cosine is positive. So it's telling us sine of theta is less than 0. So they're telling us sine is negative. And cosine of theta is greater than 0. So cosine theta is positive. So in what quadrant would sine be negative and cosine be positive? Well, cosine is only positive in the fourth quadrant and the first quadrant, and sine is negative in this fourth quadrant, right? Sine is positive in the first quadrant. So our answer for this first one is quadrant 4. I don't have a lot of room. Getting sloppy. So that's my answer. I'll try these 3. Should I give you some time to do it, or we'll just walk through them? Tan of theta is less than 0. So that means tan of theta is negative. And sine of theta is less than 0. So sine is negative. In what quadrant is tan negative and sine negative? Well, it's not the first quadrant because everything is positive. It's not the second quadrant because sine is positive. It's not the third quadrant because tan is positive. It's the fourth quadrant. Only the fourth quadrant has tan negative and sine negative. So this answer is the same as the other one, quadrant 4. In quadrant 4, tan is negative and sine is negative. In this third example, it says cotan and secant. Well, instead of cotan and secant, since these are reciprocal identities, we could think about tan and cosine for these quadrants. Because if cotan is negative, tan is negative. If secant is negative, cosine is negative. So let's take a look. It says cotan of theta is greater than 0. So that means positive, greater than 0. And secant of theta is less than 0, so that means negative. So in what quadrant is tan positive but cosine negative? Well, tan is only positive in the first quadrant and the third quadrant, and cosine is positive here in the first quadrant, so the answer has to be quadrant 3. Quadrant 3 has tan as positive and cosine as negative. In this fourth example, again, we have secant, so in my mind, I'm thinking cosine, and cotan, I'm thinking tan, actually the same two trig functions. And it says secant of theta is less than 0, so that means it's negative, and cotan of theta is less than 0, so that's also negative. So in what quadrant is cosine negative and tan negative? Well, not in the first quadrant, because they're all positive. In the second quadrant, sine is positive, which means cosine and tan are negative. So this is quadrant 2. And that's it. And that's how we determine what quadrants these scenarios lie in. Okay, in this example, they ask us to find the exact value of the remaining trig functions given sine theta is negative 12/13, and they're telling us theta is in quadrant 3. So there's two things that some students have an issue with here. Here they're asking for the exact value. So that means no decimal approximations. Right? Your answer is probably going to be fractional, maybe have radicals in it. If it has a radical, you have to rationalize the denominator. They also tell you theta is in quadrant 3. Right? They're telling you the location of the terminal side of theta. Here they're outright telling you it's in quadrant 3. But they could also say, instead of quadrant 3, they could say theta, where's quadrant 3? Is greater than 180, but less than 270, right? That's another way of saying quadrant 3. And they could also say where tan of theta is greater than 0 and sine of theta is less than 0, right? That's another way of stating quadrant 3. So they're going to have to tell you where it is. They might not outright say quadrant 3. They might give you a little work to do to figure out it's in quadrant 3. So they're telling you the quadrant that it lies in. So we have a terminal side of theta in quadrant 3. We could create a reference triangle by drawing a vertical line from the x-axis to the terminal side. This creates a right triangle. And they're also telling us two sides of the triangle, right? This is my opposite over my hypotenuse. So theta lies inside here. My opposite side is 12, and my hypotenuse is 13. So they're giving us two sides of the triangle. I also have a negative value here. So one of these are negative. Your hypotenuse can never be negative. Therefore, the 12 is negative. You want to be careful where the negative goes, especially in other quadrants, because when we move, say in this fourth quadrant, you have to remember that this value would always be, if we were in this fourth quadrant, this would always, x value would always be positive, and this y value would always be negative for the two sides. So you just want to keep that in mind. Regardless, it doesn't really matter because you know all students take calc, so you know tan will always be positive, therefore sine and cosine will be negative in this quadrant. It's another thing you know. So before we go on to find the remaining trig function values, we need to find this side. So we're going to have to do a little Pythagorean theorem here. So we want to do our a squared plus b squared equals c squared. Right? So we could say negative 12 squared plus b squared is equal to 13 squared. 144 plus b squared is 169. I subtract 144 from both sides of the equation. B squared is equal to, looks like 25. So B is equal to 5. So we found our remaining side. It's 5, but since it's to the left of 0, it's going to be negative 5. So now we have all three sides, so it's easy to find our remaining trig functions. Let's write them out here. We're going to have sine, cosine, tangent, cosecant, secant. So let me write them down here. Hold on a second. So these are the 6 trigonometric functions, right? When we were given sine is 12 over 13. I know cosine is my adjacent over my hypotenuse. Tan is opposite over my hypotenuse. And then here we have the reciprocals. O, ha, and A over O. So in this case, my adjacent over my hypotenuse would be negative 5/13. Tan is my opposite over my adjacent, which would be negative 12 over negative 5, which is 12/5. And then we have all the reciprocals. So I don't have to do any work. I could just look up here. This will be equal to negative 13/12. This will be negative 13/5. And this will be 5/12. And we could see that this is true. Tan and cotan are positive, and all my other trig functions are negative. So we've answered this question. So here they're just asking us to find the reference angle. This is relatively easy, I think, right? They're telling us in this first one, and we know 0, 90, and 180. They're telling us our terminal side is at 170 here. So if I'm looking for my reference angle, I could make a reference triangle here. So I know the value here has to be between 170 and 180, which would be 10 degrees. So my reference angle is 10 degrees. It's this angle. In this next example, it says 351 degrees. So I'm going to have to go all the way around to my fourth quadrant. Right? I know that this is 360. I know this is 351. This is 270. So I know it's in the fourth quadrant because it's between 270 and 360. I create a reference triangle. I'm looking for this angle in here. From 351 to 360 is 9 degrees, I believe. That seem right? I think we're good. Negative 250 degrees. Negative 250. Well, I know that's negative 90, negative 180, and I know this would be negative 270. So it would have to fall somewhere in here, negative 250. So when I make my reference triangle, the angle is between negative 180 and negative 250. So I believe that's 70 degrees, right? From negative 180 to negative 250 is 70 degrees. So theta prime is 70 degrees. By definition, a reference angle is acute. Acute means it's between 0 and 90 degrees. So therefore, it's always positive. Right? So here, some people might ask, oh, is it negative 70? It's not negative 70 because reference angles are always positive. They're acute angles. They're interior angles of a triangle. 553. Well, I know that this is 360. And to bring it up here would bring me to 450. And this would bring me to 540, and this would bring me to 630. Therefore, this angle has to be in this third quadrant. 553, I believe, would be in here. So my reference angle is between 540 and 553. It looks like my reference angle is 13 degrees. From 540 to 553 would give me 13 degrees. And lastly, this 11/4 pi, well, we could do this two different ways. We can convert 11/4 into degree, from radians to degrees, or we could work it in radian form. If we're going to do this in radian form, which would be the way you want to do it in pre-calculus, let's rewrite this as a mixed number. Instead of 11/4, this is really 2 3/4. Pi. And if we think about this, 2 3/4 pi, where would that bring me to? Well, I know one complete circle is 2 pi, right? And then if I continue this, that would be 1/4, 2/4, 3/4. 2 3/4 pi would bring me there, right? Because we got to remember this is 2 pi, and if I go all the way around, this would be 3 pi. All right, this would be 2 pi, this would be 2.5 pi, this would be 2 3/4 pi. So my reference angle is here, or rather my reference triangle is drawn here. My reference angle would be in here between 2 3/4 and 3. So you could do the subtraction there, right? 3 pi minus 2 3/4 pi, which we know is going to be 1/4 pi. Even if you did this in terms of degrees, which you could do, we can convert it to degrees and then get your reference angle. But in the end, since the question was proposed in radian measure, you have to give the answer back in radian measure. So once you complete this, you would have to convert it back into radians. So you're better off just sticking with radian measure. So the last thing they ask of us in this section is to find the exact value of each of the given trig functions. So in this first example, they give us sine of 300 degrees. Well, what do I know about sine of 300 degrees? Well, I know sine is my opposite over my hypotenuse. All right, where would 300 degrees be? I know 300 degrees would be more than 90, more than 180, more than 270. 300 degrees would be here in the fourth quadrant. So I can make a reference angle here, or a reference triangle. If this is 300 degrees, and I know this is 360, well then this has to be a 60-degree reference angle. And if this is a 60-degree reference angle, then this has to be 30 degrees. This is a 30, 60, 90 triangle. And if it's a 30, 60, 90 triangle, I know what all the sides are. Across from my 30 degrees would be my smallest side of 1. Across from 90 would be my longest side of 2. And across from 60 would be my medium side of radical 3. 1, 2, radical 3 triangle would be the ratio. This is a special triangle. So if I know the 3 sides of the triangle, then I could go back here, my opposite over my hypotenuse. My opposite is radical 3, and my hypotenuse is 2. So the first thing I want to do is I want to find my terminal side, find the quadrant it's in, create a reference triangle. In this case, it's a special triangle, so I could find all the sides, or I know all the sides. In fact, my only error here is this should be negative radical 3. All right, with that being negative radical 3, so my answer is actually wrong. This should be negative radical 3 over 2, which I should know this answer is wrong because it's in the fourth quadrant. And in the fourth quadrant, the only thing that's positive is cosine, right? All students take calc. So sine has to be negative. This is a negative value because it's a negative in my y-axis. So that's it. So all you have to do is find the terminal side, do the find the 3 sides using a special triangle, and then you could find the values. I'll give you a second to try some of these. Right, what quadrant would 405 be in? So 1 full rotation is 360. And this would be 450. So it looks like I would be here in this first quadrant. And if this is 405 and this is 360, well, that means this is a 45-degree angle. And if that's a 45-degree angle, then this has to be a 45-degree angle because they have to add up to 180 degrees, right? These are always complementary angles. And if that's 45 and that's 45, well, then these 2 sides are the same. This is a 1, 1, radical 2 triangle. It's a special triangle, 45, 45, 90, which is 1, 1, radical 2. So tan is my opposite over my adjacent. So from this angle, this is my reference, my point of reference is where I'm standing. My opposite is 1, and my adjacent is also 1. This looks like it's 1 over 1, which is 1. So tan 405 is equal to 1. You could probably check that on your calculator also. Seven fourths, again, I would rewrite this. I'd write this as a cotan of 1 3/4 pi. And I know 1 pi is there, right? And 2 pi, this would be pi, this would be 2 pi. So this would be 1.5, and 1 3/4 would be here. Right? This would be 1 1/4, 1 2/4, 1 3/4. Right? So that's where my 7/4 pi would be, or 1 3/4. And I know 2 pi is here. So my reference angle in this case, not the best, but is 1/4 pi. And 1/4 pi is 45 degrees. So once again, this is a 45, 45, 90, with this side being 1, this side being -1, and my hypotenuse being radical 2. 1, 1, radical 2. Cotan is a reciprocal of tan, so it's A over O. So my adjacent is 1, and my opposite is -1. In this case, cotan of 7 over 4 pi is -1. So these the same thing, -225. So I start at my initial side, negative, I'm going to go down. This would be -180. And this, if this is -180 and this is -270, it looks like -225 will be somewhere here in the second quadrant. So my reference angle is between 180 and 225, which once again is a 45-degree angle. All of these, in order to find the exact value, you need to know all the sides of the triangle, and that's why in this case they're giving you all special triangles. So this would be a 1, this would be -1 over here because it's to the right of 0, and radical 2, 1, 1, radical 2. Sine is my opposite over my hypotenuse. So my opposite is 1, my hypotenuse is radical 2. So I have to rationalize this denominator. So my final answer here is going to be radical 2 over 2. Radical 2 over 2. Positive 510. Well, I know that that's 360, and this is 450, right? Because I'm adding 90. This is 540. So we're over here. Between 450 and 540 would be my terminal side of theta. I can make my reference triangle. This is 510 degrees. This is 540 degrees. So my reference angle in this case is 30 degrees. So once again, this is a special triangle, 30, 60, 90. So I know it's a 1, 2, radical 3. In this case, since I'm to the left of 0 here, this is a negative radical 3. This is positive on my y, so that's positive. So my 1, 2, rad 3, my smallest angle is always across from my smallest side. My largest angle is across from my largest side. Secant is the reciprocal of cosine. So it's half. So it's my hypotenuse, which is 2, over my adjacent, which is negative rad 3. So I have negative 2 over rad 3. I'm going to have to rationalize that denominator by multiplying the top and the bottom by rad 3. So it looks like my final answer is negative 2 rad 3 over 3.